The most important engineering feat of the modern age that we all take for granted is the power grid. And here's how it works. First of all, the power grid is always on. Second of all, the grid doesn't store a lot of energy. The power plants that feed the grid are constantly adjusting output to meet demand, which means the grid is always living in the now.
That's so meta!
The grid is designed to get power from the places that make it to the places that need it, when those places are usually not in the same place. Most of the time, they're very far apart from each other because no one likes power plants.
At least not in my backyard.
The problem is, we use relatively low voltages, like 110 volts. But to efficiently transmit electricity long distances, you need really high voltage, like 230,000 or 500,000 volts. This can be dangerous in the house. The other problem is that power plants can't generate high voltage, so what's needed is electricity that can be easily manipulated, stepped up to high voltage for transmission and stepped down to low voltage for distribution. Thanks to Nikola Tesla, we now have AC, which stands for
Animal crackers?
No, alternating current, which just means that the charge of the wire alternates between positive and negative. Alternating current is the only current whose voltage can easily be manipulated. To do this, all you need is a transformer.
Cool!
Transformers are the key to the power grid.
That's a transformer?
They're basically just coils of wire, but they make repackaging electricity possible. One type of transformer takes electricity from a power plant and steps it up to high voltage for transmission. On the other end of those lines are other transformers that step that voltage back down for distribution. More transformers, like the ones you see on neighborhood utility poles, step the voltage down even further, so it's safe for your home. The electrical grid is a network of power plants and transformers connected by miles and miles and miles of power lines carrying different amounts of voltage. In the United States, the grid is divided into three main smaller grids called interconnections. There's the Western Interconnection, the Eastern Interconnection, and the Texas Interconnection. Don't mess with our interconnection! Each interconnection is governed by either a single control center or a consortium of control centers that monitor and regulate the flow of electricity with thousands of sensors. Since the demand for electricity is changing all the time, and the power cannot be stored, the control centers are continually adjusting how much power is being generated and where it's being sent. But things could be better. For one, the actual physical infrastructure needs to be updated. A lot of the equipment is over 50 years old and requires constant fixing. Another improvement would be the much talked about
smart grid.
The smart grid is a fashionable term used to describe the power grid with improvements that would make the grid more efficient and more reliable. For one, the grid needs to be overlaid with digital computers and communications, or digitized. Right now it's still analog like Grandpa's VCR. Here are the big things we could do to make the system smarter. 1. More sensors and more types of sensors. Everything from newer power line sensors, smart meters, and even smart appliances. When everything on the grid is talking to each other, fluctuations in supply and demand can be anticipated and outages can be avoided. A smarter grid is a grid with more real-time communication. 2. Decentralize more power centers. Just as Texas has its own power grid,
Damn right!
if cities had their own self-sufficient microgrids, they would be more prepared for power demand fluctuations. 3. Build mega battery arrays for the grid. Energy sources like wind and solar are only sources of energy when the sun is shining or the wind is blowing. With huge battery arrays, energy can be stored for use when these sources are offline. Also, let's say the wind is blowing when demand is low. Right now, wind turbines would be shut off and valuable wind energy would go to waste. With a big battery, we could store this energy and use it for later. Ultimately, as our energy demands and energy sources change, traditional power grid models aren't sustainable. In the future, we need to be smarter about our power infrastructure.